everybody, this is Rudra Pradhan here and welcome you to BMDA course. So, today the topic of discussion is descriptive analytics, that too we are here to highlight the unit 3 lecture, and in the previous two lectures we have discussed about the introduction to business analytics and exploring data and analytics on spreadsheet. So, technically we have discussed details about the business analytics requirement, the tools and the importance, the applications. So, accordingly as per the requirement of analyzing any business problem through business analytic tools. So, the first hand requirement is the data, and that is how in the unit 2 we have discussed the data in various angles. So, like understanding the data, data view, data visualizations, and we have discussed various tools, graphical tools and quantitative tools to understand the data, to visualize the data, and then make the data in a particular structure, so that we can analyze in a better way as per the problem requirement, and then solve a business problem. So, here we will go a little bit more, and that too the particular requirement of analytics tools. So, so the discussion is like this. So, in the last class or in the first two units we have drastically highlighted the classification of business analytics tools. So, business analytics tools basically divided into three groups. So far as the discussion is concerned to take some kind of management decision. So, the first one is descriptive analytics, second one is the predictive analytics, third one is the prescriptive analytics. So, these are all discussed earlier. So, just I am highlighting so that we can connect with the today's discussion. In the descriptive analytics, the basic idea is to discuss what happened in the past, and knowing the past kind of trend or the structure. So, the predictive analytics will analyze the particular requirement, and then like to answer the questions what will happen in the future. Then on the basis of descriptive analytics and predictive analytics, prescriptive analytics is the structure where we have to find out the best possible actions. That means the optimum values of the decision variables. So, now here we are in the process of discussing the descriptive analytics, and as per the earlier kind of discussion. So, these are the various tools available under descriptive analytics, predictive analytics and prescriptive analytics. And in the case of descriptive analytics, so we have a data types and scales, measurement of central tendency, measures of variations, measures of shape and data visualization. And in fact, we have already discussed details about the data types and scales, and the kind of understanding, the kind of structuring, restructuring, and that we have already discussed in the unit 2. So, now here we will directly start with some of the basic tools that is under the descriptive analytics. So, let me highlight what are the components we are going to discuss in this unit. So, that means the idea is that what should be the unit coverage for this discussion. So, the coverage will be measures of location, measures of dispersion, measures of shape, Excel descriptive statistics tool, descriptive statistics for group data, descriptive statistics for categorical data, measures of associations, and then something the basic requirements of probability and probability distribution, and then sampling with sampling distributions. So, that means basically these are the coverage which we will cover in this particular unit, and for that you must know the kind of problem, and to analyze the problem you must actually recognize the variables, decision variables, and then you must have a data corresponding to each variables. Depending upon the data or information corresponding to a particular variable and your problem's requirement or problem kind of structure. So, you like to use a particular tool, and then you can analyze the problem. In fact, descriptive analytics is not a kind of complex process or kind of complex kind of environment. Here you are supposed to know something, so that that can be analyzed in a much better way through predictive analytics and prescriptive analytics. So, that is why first the descriptive structures, then we will go for predictive structure and prescriptive structure. In some instances, the descriptive analytics can also help to analyze certain problems, and you may be in a position to get some kind of management decisions. So, let us start with the kind of discussion. So, the first component under the descriptive statistic is a measures of location, and there are various ways of measuring this particular location. So, standard three measures are mean, median and mode, and this is otherwise called as a central tendency, and the entire particular structure is also called as summary of statistics. So, here the idea is you have a variables, and corresponding to variable you have a plenty of informations, that is what we call as a sample observations, and you are supposed to know what is the central point of this particular spreadsheet or data. So, for instance, suppose you have actually 100 data points for a particular variables, and it is mandatory to know, or it is the requirement of business analytics to know what is the average of this particular series, what is the maximum of that particular series, what is the minimum of that particular series. Of course, we have already discussed slightly in the use of Excel sheet, that is Excel spreadsheet, but still you are supposed to know whether you are using Excel spreadsheet or any kind of statistical softwares. So, the standard requirement is you should know the description about a particular variable, and the description of a particular variable can be analyzed with respect to the descriptive statistic, that is what it is called as descriptive analytics. So, now these tools are frequently used to know the or to understand the nature of the data for a particular variables. So, here we are discussing about the particular measures, and the measures are nothing but called as measures of central tendency, and the standard measures are called as mean, median and mode. So, these are all very simple, but still you have to know, and you have to calculate, and you have to report. So, that it will give you some kind of shape and some kind of structure. So, since it is a kind of empirical kind of investigation process or statistical kind of investigation process. So, always the game is with respect to population and sample. Population means it is a big set, and sample is a part of it. So, our entire structure or the problem discussion or problem analysis depends upon sample space is particular sample case only. So, it is sometimes very difficult to catch population. The population means the entire data for a particular variable, which may not be feasible in a real life scenario. So, that is why most of the instances we use samples, and in the sample data you have to analyze as per the kind of problem requirement. So, in the standard measures of kind of mean is like this. So, it is something called as sum of the total observations, sum of the totals divided by sum of the total observations. For instance, x is a variable. So, different items or different numbers are available with respect to x, and then we like to know what is the average of this item. So, just the simple structure is just add up all these variables, means values of the variables, and then divide by number of observation, then you will get actually simple statistic. That is what it is called as actually mean. And whether it is a population, whether it is a sample, so the formula or the structure is almost all same. So, you have to just add on, means adding all these items. So, that is nothing but sum of the values of the variables, and then divided by number of observations. Then after that you will get a component called as average. So, here actually in the Excel, so this is the operation you have to apply. Just you go to the end of the data set, and then put equal to signs, and give the command of average, and then specify the range, particular range. If you specify the entire range, then it will give you the mean of the entire range. If you specify mean of a particular range, then it will also give you mean of a particular range. So, that means it is the beauty of the particular statistics, and the beauty of Excel spreadsheet or any kind of statistical software. So, it will give you different kind of structures, or the idea is to find out the central point, and that can describes the entire things as per the requirement. But by the way, so these are all typical features when we will reporting the measures of locations. So the mean should be actually in such a way that any sum of the deviation of the mean from the observations should be equal to 0, and sometimes this may affect this particular feature if there is a presence of outliers. In fact, we have discussed the concept of outlier in the unit 2. So, outlier means it is the data point which is highly distant from other data point. For instance, suppose there is a variable and the data entries are all are in single digit and double digit, but one data point may be in triple digit or like that. Then in that case there is high chance that mean will not be stable. So, it will affect the particular process. So, likewise, so there are lots of other measures. So, this is actually standard examples. This is a kind of purchase order data, and then so these are all entry. So, we have already discussed the Excel kind of entry, the kind of understanding, all these things are there. So, now for instance, we here the requirement is mean cost per order. So, that means, so here if you go through G columns, then this will give you a cost per order. So, then you are interested to know what is the mean cost per orders. Just you go to the end of this particular series and put equal to sign, and then ask the Excel to give the average, and then by default you will get the value of this average is like this, right. In fact, mathematically you can calculate, but spreadsheet by default will give you such value, and by this particular process you can able to know what is the structure of the data, and then you can also verify the data from the central actual point to mean point. So, if the sum of this particular deviation is coming 0, so that means there is a high accuracy in this data, and that data can be analyzed in a nice way to represent something. And then okay. So, likewise, so you have actually another kind of structure here called as weighted mean. So, like it is a part of mean structure, and here the idea is summation of x divided by n. Instead of doing that, so here it is the summation of w x divided by summation w. So, that basically it is nothing but actually like frequency distribution. So, that means earlier we are adding all the values of the variable and dividing by sum of the observations, and to know what is the center of this particular spreadsheet. So, this will give you the idea what is the shape of this particular data or the position of the data. Your problem may be different, but let us say the example is it is a kind of sales data in various locations for a particular point of time. So, you like to know what is the average sales in these locations. So, then accordingly you can actually get to know which particular location has a high sales, which location has a low sales, and then after reporting the mean you can find out the particular difference. If the difference is high or low, then the kind of problem requirement is also analyzed accordingly. So, now this is another kind of structure where you can also calculate the mean, and this is nothing but called as a weighted average, and here against each variable you can actually give some kind of weight factors. So, as a result, after adjust with the weight, then you can calculate the means. Okay. So, this is sometimes this is one kind of requirement for some kind of investigation process. So, then there is other measures of means like arithmetic mean, harmonic means, then geometric means. So, these are all different ways of reporting the mean, but ultimately the idea behind this particular structure is you have to find out the center points, and then you like to check how these values of the variables are means what is the exact difference values of the each variable or each data point from the mean data points. So, this is another kind of measures, another kind of measures. So, where we like to know what is the middle of the particular series. So, median is the kind of figure which can divide the series into two equal parts. but mean may not divide into equal parts, but it will give you a center points through which the entire variables can lying. Some may be high, some may be low, but it will give you a specification where 50% of data will be left side and 50% will be right side, or 50% will be up and 50% will be down. So, this is how the kind of structure you have to follow, and this is the formula which you can use to calculate the median. So, if it is the series is can say odd, then simply divide by 2. So, then you can get the value value of the median. So, even if it is even number, then you can actually divide the nearest two values, and means adding nearest two values, then divide by 2. So, then you can get the value of the median. So, this is another measure of kind of location. And for group data, so for instance something kind of interval kind of situation. So, then you can use this particular formula, but ultimately we are not here to mathematically calculate all these value, but this is I am just showing that for every kind of tools, analytics tools, descriptive analytic tools, you have actually mathematical formula, and software by default will give you all these values by directly, and then you can get these values of the variable or values of the statistics, and then with the help of these statistics you can analyze the problem. So, this is a kind of formula, and here this formula is simply used for calculating median. So, L stands for lower limit of the series, then N stands for sample observations, then F is the frequency, and CF is the cumulative frequency, and H is nothing but called as width of the median class. So, then accordingly you can calculate. I will take an example, then I will show you how to calculate in the Excel sheet, right. So, this is how this specific examples what I have already mentioned. So, this is the kind of data structure. So, now here this is the range of the data, and you can actually put lower range and upper range, then you can streamline the particular process, and this is what the frequency, and this is cumulative frequency, and the particular structure can be represented graphically also, graphically to find out the medians, that is nothing but called as OGIE. And then we can do through less than methods, and then by kind of more than methods. In the less than methods, you are supposed to check this part of the series, and then the cumulative frequency, So, then if you plot, then the figure will be coming like this. Then the other side, if you go to the other part, that is the more than type methods. So, you have to take the lower limit, this part, this lower part, and then you have to use the cumulative frequency. Again you can with respect to this range, you can plot this particular item. So, then you will get the figure like this. Then if you join the the first one and the second one, then the intersection point will give you something called as median. So, the intersection point will give you something called as medians. So, now, so these are the things you can actually you can report from this descriptive statistics, and then accordingly you can actually analyze the particular problem. This is another kind of measures called as mode, and highest frequency distribution or highest frequency in a particular particular set, data set, can give you the kind of mode representations. So, like mean and medians, mode is also kind of measures which can describe the values of the variables, that specifically again indicate you that what is the distance of individual points from the central point. So, this is the formula which you can use for calculating mode. And in fact when we have a data and with respect to time or any kind of cross sectional unit, so then the idea is just you have to visualize the data by different plotting, and then here the idea is you have to check the kind of distributions. Usually we follow a kind of normal distributions, whether the data is follows a normal distributions or not normal distribution. So, we have a lots of distribution which we discuss after some time, but usually if the data is in the kind of normally distributed, then it will give you some kind of consistency results, and most of the things can be in a right path. So, that is how we are always try to do some kind of adjustment, so that the data should be normally distributed. If not actually normally distributed, then it will be called as skewed data. It may be right skewed, it may be left skewed. So, for instance, here the idea is symmetrical data. So, this is what actually when the data is symmetrical means, so it has actually equally kind of distribution. If you put mean, median, modes that will be coincide, then the data will be equally spread. So, but if not, then few data will be more in the right side or few data will be more in the left side. If it is more in the right side, then it will be called as a positive skewed, or if not, then it will be called as left skewed or negatively skewed, right. So, this is how the particular structure through which you can calculate all these mean, median and mode. Okay. So, the other parts of this particular measures of location is the measures of dispersion. So, that means in the descriptive analytics. So, one part is measures of location, this is a measure of dispersion. That means you like to know what is the kind of structure of data once again to analyze this problem. So, there are various tools are there, so like earlier mean, median, mode. We have here range, variance, standard deviations, mean absolute deviations, absolute average deviation, interquartile range. So, many things are there, and here the idea is again to know the spread of this particular series. The spread of that particular series will give you enough exposure to understand the problems and understand the variable, and then you can predict the particular environment, right. So, this is a kind of slight examples. So, now particularly when there is a kind of comparison. So, because we are dealing with business related problems, and then you have to always have some kind of comparisons, because we are living in the competitive environment. So, let us say there are two series here, sample A and sample B, sample A and sample B, and in this case we like to know which particular series is more consistent. Then this is the tools which you this is the tool which you can use to solve this problems, or here to justify which one is more consistent. So, just you find out the variations or variability. So, either through standard deviation or variance, then you can report actually where the variance is high, then that is less consistent, and where the standard deviation is low. So, it is called as a more consistent. So, likewise you can solve some of the business problems depending upon the particular requirement. So, this is another kind of tools, descriptive tools, that is called as a range, which can give you the difference between maximum and minimum. If the difference is actually 0, so that means this particular data set will not be useful for any kind of investigation process. So, your range should be always actually some positive value, okay, some positive value, and then if it is equal to 0, so then analytics tools may not be used for further kind of. This is actually a mean component, and this is the individual observations, and squaring these distance from the actual point to mean point, and then adjusted with degree of freedom, that is the sample observations. And we like to know what is the kind of possible. If larger the deviations, larger is the means lower is the consistency, and lower is the standard deviation, higher is the consistency, but it should not be equal to 0 again, like range should not be equal to 0, standard deviation should not be also equal to 0. If standard deviation equal to 0, then again this particular data set may not be used for any kind of investigation process. So, you must be very careful how you have to deal with these problems, right. Okay. So, so this is a kind of theorems when we go for some kind of investigation process by using data. So, then you are interested to know the particular distributions, then sometimes so the data can be actually normally distributed, and the theorem says that the proportion of values that lie within, you can say k, where k greater than 1, and that too is to standard deviation of the mean, that is nothing but actually 1 minus 1 by k square. So, that means actually most of the observations follows like this. So, if approximately 60-80%, then it will be a kind of interval, either otherwise it is a 95% interval or it is a 99% kind of So, it depends upon mean with standard deviation only, mean with 1 standard deviation, mean with 2 standard deviation and mean with 3 standard deviation. Mean with plus minus 1 standard deviation means 60-80% data will be in the particular zones. Otherwise, if it is a mean plus minus 2 standard deviation means 95% of the data will be lying in. Then mean plus minus 3 standard deviation means 99% data will be lying in these particular structures. Okay. So, this is another measure of dispersions, coefficient variations. This is actually relative measure, and the entire structure can be actually transferred into a percentage format, and then you can make some kind of comparative analysis. It is just the ratio between standard deviation to mean followed by a percentage, right. So, this will be very easy to have some kind of comparative analysis. Then the next measure is interquartile range, and that is the difference between third quartile and the first quartile. So, when you are plotting the data, so you have a 25% data, that is the first quartile, then 50% of data, that is the second quartile, then third quartile is the 75% of data. So, that means so if we actually data is equally spread, then this will be actually give you some kind of better structures. So, interquartile range, that is nothing but called as IQR. So, we will give you some kind of snapshot whether the data is well spread or not well spread. So, this will be helping lot again for further kind of investigations. Then if there is outliers, the outliers will be problematic to make the kind of statistics more consistent. So, so when we like to use all these statistics to report something, so be careful that outlier should not be in the process. If there is outlier, you try to remove the outlier and then analyze the problem. Otherwise, the entire result will be inconsistent altogether. Okay. So, this is the standard examples of outliers. By box diagram you can find here the median is location is here, but high point high structure this side and low structure this side. So, that means outlier will affect the particular process. So, what is the best requirement that remove the outlier, then again restructure the process, right. So, this is the third measures of descriptive analytics. So, that is called as a measures of safe, and here there are two type of requirement, that is called as a skewness and kurtosis. So, skewness it will give you actually spreadness of a particular distribution, which I have already discussed about the concept called as a normal distribution. And when this distribution is symmetrical, then mean median mode will be coincide. If the distribution is not actually symmetrical, then it will be either right skewed or left skewed, and that is what actually the structure called as shape of the distributions. So, now skewness and kurtosis will give you some kind of better exposure to know the shape of this distribution. So, this is the standard examples, and here this one is actually called as equal spread, and this is actually not skewed, and this is actually not skewed. This is called as positively skewed, and this is called as negatively skewed. So, that means this is not well distribution, but this is actually perfect distribution, and when your data will be like this, then your analysis will be very perfect and your findings will be very perfect, and you can have a perfect decision. So, if your data is not actually very accurate, then it will give you some kind of wrong decision. Okay. So, this is another measure of measures of shape, and same as Excel will help you lot to get these values of the variables. So, now like skewness, kurtosis will also give you some kind of exposure to know the shape of the distributions. Okay. So, the structure will be this structure will be like this. It is kind of flatness of the curve, right. So, this is actually these are all various shapes of the distribution, and kurtosis will give you some kind of shape like this, but that means this is actually the correct kind of specification. For instance, so the red one is actually the correct shape of the distribution. If your data will be in this particular structure, then it will be actually having high kind of impact, and the decision will be very perfect. Otherwise, it will be little bit inconsistent kind of decision making process. Okay. So, this is the standard examples, and then these are all various ways you have to report the descriptive statistics. And okay. Okay, so let me take you to examples and show you how these actually the shape of the all these descriptive statistics can be reported. For instance, let us say so this is actually series here, and what will we do here? Okay, so I will let it be big one. Okay, so let us say this is a series here. I have actually randomly generated here 10 to 15 to yes 10 to 50 here. So, that means just you create a, let us say x is a variable here, and then you just randomly generated data something else, random data between say 10 to 50, and then close the loop and make enters. Okay, so this will be, then you take some series of the data, like let us say this much of series you have generated, and the range is between actually 10 to 50, because it is a random data. And then our idea is just to know how the descriptive statistic is all about in this particular series. So, what will you do actually? So, just highlights this data. Okay, so highlights this data and go to the data here, and then here there is actually data analysis package, and you just go to the data analysis package, and then here there is a component called as descriptive statistics. Just you put OK, and then by default it will ask you to specify the range. For instance, our range is here how much d to say d like 13s, the entire range. Okay. Then you just see here so many items are there, and then you just click summary statistics and then put OK, and by default you will get standard results like this. Okay. So, just I will enhance so you can get to know actually. So, these are the actually descriptive statistics which you have already discussed. So, you from the data set, this is actually variable x, and the original data set is a original data set sorry. Okay, so this is the kind of statistics, and so the values of the variable may differing from 10 to 50, but the mean value is here 31, and standard error is this much, median is 35. That means we have calculated for some of the observations at 12 observations. So, median is showing 35, mode is 35, and mean is 31, and then standard deviation is 12, then sample variance is 144.7, and kurtosis is minus 1.05, skewness is minus 0.24, and the range is 37, minimum is 12, maximum is 49, and the total sum is 382. So, that means these are basic statistics which we have reported through descriptive analytics. So, that means the variables informations are readily available from particular point to particular point. So, you want to know what is the nature of this particular data corresponding to this particular variable. So, this descriptive statistic will give you some kind of exposure to know about to know more about this particular variables. If the data structure is not perfectly okay, then it will not help you a lot to take some kind of management decision. And as a result, descriptive statistics through descriptive statistics you can get to know whether the data which is available for this particular variables, or for few variables are consistent or not. So, this is the reporting for a particular variable. If you have a series of variables, then every variable can be analyzed in with these test statistic and descriptive analytics tools. So, in any kind of problem investigation, when you have actually variables and the data, so it is the standard requirement is that you have to report the descriptive statistic and get to know details about this particular variable so far as past data is concerned. We have discussed the concept called as descriptive analytics, where to know what happened in the past. So, that means this is the kind of summary statistics, and this summary statistic will give you some kind of snapshot what was actually happened in the past. So, that means what is the average kind of structure, what is the maximum kind of structure, minimum kind of structure, what is the variations, how is the kind of range. All these things are you can explore with the available historical data. That is what we call as past data. Once you know all details, then you will be in a position to go for further kind of investigation through predictive analytics and prescriptive analytics. But it is the mandatory requirement that you are supposed to know details about this particular variable so far as data availability is concerned. So, whatever shape of the data does not matter, whether it is a 10 observation or 100 observation or 1000 observation, just just allow the kind of software to report the descriptive statistics. Then software will by default will give you values of the descriptive statistics, and with the help of descriptive statistic you can analyze measures of location, measures of dispersions, and measures of shape. So, that means these are the three major requirements we are supposed to report in any kind of problem investigations. If you are aware about the measures of location, measures of dispersion, and measures of shape, and by default your 50% of the things are reported there. So, you are in a absolutely you are in a right position to describe the particular structure in a much better way. Until unless you know the kind of descriptive statistics, so you are not in a position to pick up a complex kind of tools to investigate the problems in depth, means more in depth, and to get better inference, and then that may help you lot. Means if you are exploring all details by this kind of structure. So, the further kind of investigations by using any complex analytics tools will be give you some kind of better inference and better judgment, and then the decision will be actually more or less perfect and consistent. So, that is how the standard requirement is for any kind of investigation process. You are supposed to identify the variables, have the data. After having the data, first you report the descriptive statistic, check the descriptive statistic, understand the situations, and after understanding the situation, then you look for further in depth kind of investigation in further kind of testing or something like that. Then you will get some kind of better inference, and that will help you a lot to to solve some of the problems, and that to take some kind of good management decisions. With this we will stop here. Thank you very much. Have a nice time.